All right, Trig class, now we're on to section 7.2, which is the graph of the other three trig functions, cosecant, secant, and cotangent. We just got done talking about sine, cosine, and tangent, and these are going to be very similar to those graphs. In fact, starting with the cosecant function, cosecant, let's see, y equals cosecant of x is the reciprocal, I guess, of y equals sine of x. And you actually use the graph of y equals sine of x, which is this guy here, it's the one in blue, to graph the cosecant function. I'm going to do just a little rough sketch of it over here so you can kind of see what I'm talking about. One full period of sine starts down here. It will go up to 1, go down to -1, and then come back up again. Here is 0, here's 2 pi, this guy down here is at -1, and this guy is at +1. That's one full period. So he'll go down and back up again. I guess this place where it crosses is at pi here. Okay. So up, down, up, that's one period of sine. So you can kind of see that guy right here. This is what I've just drawn right here. Okay. If I want to graph what cosecant is, it's just what sine is, except cosecant is like little parabolas that are branching off of the hills of the sine function. Okay. Now the cosecant function, he will have vertical asymptotes here and here and here, but it's just the parabolas that are branching off of the sine function. So if you eliminate this middle piece right here, this is what cosecant is. Okay. They want us to, on example 1, graph the cosecant function, but they want the -3 in there. So if I graph what the original, well, let's do this. To graph -3 cosecant of t, what you want to first do is graph -3 sine of t. Okay. If you don't like that t in there, just pretend it's an x. Okay, it's just a variable. We're going to graph -3 sine of t. So the normal sine function starts here and it goes like this, and here is at 2 pi. Okay, so it looks something like that. If you can see my really light handwriting there. 3, what the 3 is going to do is it's going to make it taller. So instead of here being at 1, this is going to be up to 3. So it's going to go up like this and down to -3 and back up again. Okay, and then negative, what it's going to do is instead of it going up first, it's going to go actually down first like this and then back up again. Okay. So we're going to go down. I'm going to say -3 is right here and +3 is up here. So he's going to go down to -3, up like that. That's what the -3, this is y equals -3 sine of t. That's what he will look like. And he'll continue on that way, and he'll continue on that way. That's what -3 sine of t will look like. But they want cosecant. So we're going to draw our vertical asymptotes here, and here, and here. And cosecant will just be this guy and this guy. And if we drew more, it would be here. We could continue on forever with this cosecant function looking like that. But this is what one full period of cosecant would look like. Okay. Always start graphing one of these functions by graphing the sine, cosine, or tangent that corresponds to it first. Okay. So -3 cosecant t. All right. The secant function is exactly the same scenario as what's up here, except that is with cosine. So what you're going to do first is you're going to graph cosine, and then secant is going to be those little parabolas that branch off of the cosine function. So I'll sketch him over here. Cosine, instead of starting down and then back up again like sine does, he starts up and goes down and then comes back up again like that. That's what cosine looks like. Okay. Now, this is one full period of cosine. Here's 0 and here's 2 pi. Okay. The cosecant function would be like little parabolas that, or the, secant function would be little parabolas that branch off of this guy. Well, since he's like a half of a parabola here and half of a parabola here, we're just going to draw half guys. And his vertical asymptotes would be here and here. Okay, so it kind of looks weird when we end him like on a hill, because he'll only be a half of a parabola there. Okay, your vertical asymptotes will always go through the place where he crosses the like x-axis, really. Okay, so your vertical asymptotes will be here because that's where your cosine function crosses, and here where your cosine function crosses. Same thing here. He crossed here, he crossed here, and he crossed here. That's where our vertical asymptotes were. Okay. So that's what the secant function is. Now we're going to graph this guy, which has a vertical stretch and a vertical shift. So secant is the inverse of cosine. So rather than graphing this guy to start with, we're going to graph 2 cosine of t minus 3, or 2 cosine of x if you don't like the t in there. Okay. This guy is going to vertically stretch him, so he's going to be taller than what he was normally. Normally he's just 1 up here and 1 down here. He touches 1 and -1. Now he's going to go up to 2 and down to -2. And this -3 means he's going to go down 3. So this means, I'm just going to say taller. And then he's going to be shifted down 3. Okay, so I'm going to say 1, 2. Here's where 2 is, and here's where -2 is. Okay, the cosine function normally would start here, and he would go down to -2, and he would come back up again like that. Okay, that's what 2 cosine. But they want us to move it down 3 units. So that means this lowest point, which is at -2, is going to be down 3 units now. 1, 2, 3, and he's going to be down here at -5. Okay. This point right here where he crosses is at 0, and he's going to be moved down 3 units, so he's going to be there. This guy is going to be moved down 3 units at -1. This guy right here where he crosses is going to be down 3 units. 1, 2, 3. And this guy right here is down 1, 2, 3 units also. So he's going to look something like this. Okay? So I just took kind of each point and moved each one of those points down 3 units. All right? Now, we want secant. We don't want cosine. This is what cosine is. Secant would be just these little hills that branch off of the cosine function. And since we ended on a hill here, it will be like this half of a hill, and this guy will be half of a hill here. Okay. Crying baby. If I'm going too fast through this, feel free to pause, and you can do your sketches, because these kind of take a while. I go through them pretty fast because I have graphed these about 100 times. So secant is really this guy. We can ignore this cosine function in the middle there, but it helps to draw the cosine function before you draw the secant function. Okay. Now the graph of cotangent looks like tangent. Tangent are these blue, or well, they're not blue on your sheet, but they're blue on my sheet. This this guy here is tangent. Same thing here and here. These dotted guys are my tangent functions. Okay. Cosecant isn't like secant and cotangent. He doesn't just branch off of like my tangent function. Cosecant is actually the tangent function reflected and shifted over. So if I took this guy and I flipped him around, he would go like this. But then I'm going to scoot him over a little bit. So instead of going through 0, 0, he's actually going to go through pi over 2. Here, instead of going through 0, he's going through pi over 2. And he starts and moves like that. So your cotangent function is a tangent function flipped, and then just kind of scooted over a little bit. Okay, scooted pi over 2 units over. All right, that's what your cotangent function would look like. Let's go to the back. Backside, they want us to go ahead and graph the -3 cotangent of, oh boy, horizontal shift is what they want us to do. Ooh, these are tough. This guy is a horizontal shift because he is in parentheses, and we kind of know that rule already. This would be like if we would have -3x minus, I don't know, let's say -2 squared, okay? When it's in parentheses, it's a horizontal shift, okay? So this is what we're used to seeing, and now they are incorporating that into trig functions. So we've dealt with transformations like this before, and now they're doing this stuff to us. So -3 cotangent of -pi over 4. This -pi over 4, let me erase on my scratchbook here. This -pi over 4 means that we're shifting him pi over 4 units to the right, actually. Negative means opposite, or we always use the opposite sign. So negative you would think would be going left, but it's actually going pi over 4 units to the right, okay? -3 cotangent. The 3 is going to make him taller, okay? And the negative is going to flip him. Okay? So normally I'm going to draw what normal cotangent would look like. Normal cotangent goes through pi over 2, and then here's pi, and here's my vertical asymptote, and here's what, let's see, what cotangent looks like is this guy. That's what the normal cotangent function looks like, okay? So what we've got going on here is we want to shift him pi over 4 units to the right. Okay, pi over 4 is just this length right there, where that's all we're shifting him to the right. So I'm going to move him over, and he's going to cross right here, because that's a distance of pi over 4. So he's going to cross right here, and halfway between pi over 2 and pi is 3 pi over 2. No, that's wrong. Halfway between pi over 2 and pi is 3 pi over 4. That's where this point is, okay? So we've shifted him over. That's where he's going to cross now. And now I want to do the negative 3. The negative is going to make him taller. So he's not going to be quite so bendy. He's just going to be like kind of, I don't know, raised up a little bit. And then the negative is going to flip in the other direction. So he's going to cross through that point, and he's going to go this direction. I'm going to also move my vertical asymptotes pi over 2 units. So let's do this. Now my vertical asymptote is going to be here and here. Okay, so these are my new ones. He's going to go this direction, and he's going to go like this. Okay, so not quite so bendy. He's going the opposite direction as what he was going before, but now he's shifted pi over 2 units, or pi over 4 units that direction. Okay. These are really, really hard to do. So if you're struggling, don't sweat it. It takes a lot of practice. I've been doing these a long time, so it's really not easy to do these. So, all right, they give you a little chart down here, like they did with the sine, cosine, and tangent functions. Let's talk about the period first. Secant, his period is 2 pi because cosine goes with secant, and cosine's period is 2 pi. One full cycle occurs in 2 pi. Cosecant goes with sine, and sine's period is 2 pi, so cosecant's period is 2 pi. Cotangent goes with tangent. Tangent has a period of pi because one full wave of tangent occurs in an amount of pi, so cotangent occurs in amount of pi. Even, odd, just like sine, cosine, and tangent work. And then domain and range. So domain for secant, cosecant, and cotangent. Since cosecant and secant have those vertical asymptotes, the domain, or the x values, are going to be all real numbers except the values of pi over 2, because that's where the vertical asymptotes occur. Okay, vertical asymptotes occur on cosecant at values of pi, so that's where the vertical asymptotes are, and your domain is all numbers except those places. And cotangent is all numbers except multiples of pi. So here's a vertical asymptote for cotangent. Here at pi is a vertical asymptote. There would be another vertical asymptote at 2 pi, another vertical asymptote at 3 pi, and so on and so forth. There's where your domain quits, and so it's all real numbers except values of pi. Your range for cosecant and secant is all numbers, well, cosine and sine, you remember, bounced in between -1 and 1. So if cosine and sine are bouncing from -1 to 1, and this is what your cosecant and secant values look like, your domain, or your range is going to be numbers that are bigger than 1 and numbers that are less than 1, because that's where it cuts off. Your cosecant and secant never touch these values inside of here. I'll move my pencil here so you can see. Never touch these values inside of here. So your domain is going to be all the numbers less than or equal to -1 and greater than or equal to 1. So that just means it's bigger than 1, less than -1. Okay, that's the same for both secant and cosecant. And then cotangent is all real numbers because it goes up and down forever and ever and ever. Okay, so just kind of a summary of all 3 of those graphs. All right.